have you ever just stopped and wondered how we learn to talk? I mean, really think about it. How does a tiny human brain with zero formal instruction manage to master something as incredibly complex as language? Well, it's one of the biggest, most fascinating puzzles in all of cognitive science. And today, we're going to dive right into the heart of the debate.
So it all boils down to this one huge question that has split scientists for decades. Is language an instinct? Do we pop into the world with a kind of universal blueprint for grammar already hardwired into our brains? Or is our brain more like a master detective, just piecing it all together bit by bit from everything it hears?
To get to the bottom of that, you really have to understand the two major players in this debate. Think of it like a title fight. In one corner, you've got the long-reigning champion, a theory called nativism. And in the other corner, you have the modern challenger, an idea called emergentism, or as it's often known, usage-based theory. And here's where you can see the core conflict laid out. The nativist camp on one side basically says that language is this special, separate thing in our brain, almost like a pre-installed app that's just for grammar. But the emergentist camp says, no, no, no. Our brains just use general, all-purpose learning tools to find statistical patterns in the language we hear. So it's this fundamental difference. Do we start with the rules, or do we figure them out from all the data? All right, so first, let's step into the champion's corner. We're talking about nativism. This idea has really dominated linguistics for the better part of a century, and for some pretty compelling reasons. The absolute centerpiece of nativism is this idea of a universal grammar. The theory goes that all human languages, it doesn't matter if it's English, Swahili, or Japanese, are all built on the same deep underlying set of rules. And this core system isn't something we learn, it's something we're all just born with. But why would we even need an innate system like that? Well, proponents point to something they call the poverty of the stimulus. The argument is basically this. The language that kids actually hear is a total mess. It's full of mistakes, people stopping mid-sentence, and all sorts of grammatical errors. They argue that it's just too messy and incomplete for a child to figure out the incredibly complex rules of grammar from scratch. So there must be some kind of built-in guide. But what if that's wrong? What if the input we get isn't too messy? What if our brains are just that unbelievably good at learning from it? Well, that brings us to the challenger, a really powerful modern idea that says, no, we build language from the ground up. And this is usage-based theory, or UBT for short. The fundamental claim here is that there's no special grammar gene. Instead, all of it, the entire structure of language, just emerges directly from how we use it. Our brains are these incredible pattern detection machines, and they use general cognitive tools to build grammar from everything we hear. And if that's true, wow, that changes everything. So how in the world does that work? Well, UBT says our brain uses this powerful toolkit, the same one we use for all kinds of other learning. We categorize similar phrases together, we use analogy to apply patterns we already know to new words, we chunk common phrases like how are you so they become automatic, and crucially, we store every single language experience in this incredibly rich and detailed memory. And this is just brilliant because it shows how grammar can emerge from simple statistics. You have token frequency. That's just hearing the exact same phrase over and over again, like, let me see. That repetition creates an automatic chunk. But then you have type frequency. That's hearing a pattern with lots of different words in one slot. Think, let me see, let her see, let us see. That variation is what allows our brain to go, aha, I see a pattern here, and extract an abstract productive rule. Okay, that's a really compelling theory, for sure. But a theory is only as good as its proof, right? So let's take a look at the evidence that the usage-based challenger brings to the fight. You know, some of the most powerful evidence actually comes from computer science. What researchers did was pretty clever. They built these artificial neural networks, basically simplified models of the brain with only general learning abilities. They didn't give them any pre-programmed rules. They just fed them massive, and I mean massive, amounts of language data. And guess what? The models learned complex grammar all on their own. It proved that it's at least computationally possible to learn grammar without that innate blueprint. And the crucial point here is that this isn't just about computers. Studies of actual children find the exact same thing. For example, why does a little kid say, me do it, instead of I do it? Well, it turns out there's a direct statistical link to how often their parents say high-frequency chunks like, let me do it or give me that. The errors they make are a direct echo of the statistical patterns they hear around them. It's not random.
Okay, so this is a fascinating academic duel, but you might be thinking, why should I care? Well, it matters a lot because the answer completely changes how we approach real-world language challenges. Everything from helping a child with a speech delay to trying to learn Spanish as an adult.
If you've ever tried to master a new language, you've probably run into this incredibly frustrating brick wall. It's called fossilization. It's when you make a mistake, and that mistake just becomes a permanent, hard-to-break habit. And usage-based theory explains this perfectly. If you practice an incorrect phrase enough times, your brain does what it's designed to do. It automates it. Through that chunking mechanism we talked about, you've literally trained your own brain to make that mistake on autopilot. That's why it's so incredibly difficult to fix.
And this is where the rubber really meets the road. In language therapy for kids, the focus is now on giving them tons of high-quality examples, really high-volume input, just to help their brain's pattern detectors kick into high gear. And for those of us learning a second language, it shows why a little bit of explicit grammar instruction can be so powerful. It forces you to consciously notice new patterns that the habits from your first language might be making you blind to.
So, back to our title fight. Has the challenger, usage-based theory, delivered a knockout blow to the old champion? Well, not quite. Like any great scientific story, this one is very much still unfolding. You see, the usage-based approach still has some really tough questions to answer. Some critics say it's so flexible it's hard to make specific testable predictions. And then there's the really deep puzzle of abstraction. How exactly does a brain go from memorizing a concrete phrase like "the dog tickles Mary" to creating an abstract rule like subject-verb-object? These are the big frontiers that researchers are tackling right now.
And so we're left here, right at the edge of what we know. This whole debate keeps pushing us closer and closer to figuring out the very nature of the human mind. It leaves us with this final thought to chew on. Is language a perfect blueprint that we simply inherit? Or is it a magnificent, complex masterpiece that each of us builds one single experience at a time?